And our last problem for today, number 3, the length of a rectangle is 6 meters more than its width. If the area of the rectangle is 135 square meters, what are the dimensions of the rectangle? So if we look at that first sentence again, it says the length of a rectangle is 6 meters more than its width. Well, we don't know what the width is. They didn't tell me anything about the width, so my favorite thing to call something I don't know is x. So the width is x, but I know the length is 6 meters longer than that, or more. So I know that the length is x plus 6. And they told me the area is 135 square meters. So if you look at number 3, now that we've taken the problem and drawn the picture, it's very, very similar to number 1. So we're going to look at how can we set this up using the fact that we know area of a rectangle is length times width, and solve for x, which lets us find the dimensions. So length times width, the length is x plus 6, and the width is x. So length times width equals the area, and the area is 135. So we need to distribute on the left-hand side, and I know that looks a little weird to have the x at the end. Usually we would write that out front. The only reason I wrote it this way was because the formula is length times width. Multiplication, if you remember, is commutative, so it doesn't matter what order we multiply in. So we could have written this x out in the front if we wanted to. We're going to get the same thing when we distribute, so that's okay. So we're still going to distribute this x. So x times x is going to be x squared, and x times 6 is 6x. So now we need to move our 135 to the left so that we can use the zero product property, hopefully, and not have to use quadratic formula. And I keep saying hopefully. Some of you might like the quadratic formula, and that's totally fine. I like the fact that it works. It is a fabulous, fabulous tool, but I do like factoring personally better just because it's faster for me and a little bit easier to see. But if you find yourself struggling with factoring, anytime that we get these set up into standard form equal to 0, if you want to use the quadratic formula, you certainly can. But I'm going to try to factor. So we want to know if there's anything that multiplies to negative 135 and adds to 6. 135 divided by 5 is not going to work. Yes, I am using a calculator and checking right now. Since it's negative, one's going to be negative, one's going to be positive, and it's going to be negative 9 and positive 15. So don't get frustrated on these diamond problems. Still take your time. I'm using a calculator the same as you are. I'm just not showing it to you on the screen to divide 135 to find factors that work. So negative 9 times positive 15 gives me this negative 135, and then negative 9 plus 15 gives me the positive 6. So I had to use the same strategy that you're using, so be patient. Well, that means I get x minus 9, x plus 15. If we set each factor equal to 0, we're going to get x is 9 and x is negative 15. But we know that can't be our guy because we can't have a negative distance. We're not going to have negative 15 meters. That makes no sense. So we're going to have a length, we're going to have a width, and we're going to use the fact that x could be 9. So our width is just x. So that means our width is 9 meters. Our length is x plus 6, or if we go back and read the question again, the length of a rectangle is 6 meters more than its width. Well, if the width is 9, 6 more than that is 15. And I don't think I mentioned this in question 1 and question 2, but once you have your answer, you should definitely check. the area we know is 135 square meters. That means when I take the length times the width, I better get 135. So if I take 15 times 9, I do in fact get 135. If you look up at number 2, I know you can see it up here. 11 times 6, length times width, is 66. So we do get those answers that we need. So make sure that you remember you can always check your answers as well.